Good afternoon, everyone, and welcome to this monthly webinar. I'm Barry Borman. I'm the chair of PHONZ, and as I said, welcome to everybody. It's my pleasure to introduce Dr. Yuli Mulner, who's going to give the webinar today. Yuli is Managing Director of Epi-interactive in Wellington, and he's done a lot of work in the IT area, but now has his own business with his wife Petra, and they've used a lot of integration of IT with health and particularly animal areas. So Yuli, thank you for giving up your time to give the webinar for PHONZ today, and I'll pass over to you.
Thanks, Barry, for the introduction. So kia ora, and yeah, privileged to speak at the Public Health Observatory and to get a chance to give the presentation. So I think the plan is 45 minutes. So I have got a couple of slides. I also like to show some of the dashboards we created and the work, some of the work we've done previously. And then I believe at the end we have roughly around 15 minutes to answer any questions. So it'll be good to get a bit of a discussion going. And yeah, so for today's session, it's got the title From Spreadsheets to Operational Outputs, and I'd like to present some case studies in enabling human, animal, environmental health intelligence. So maybe briefly, I've got three parts of it. So I'd like to dive a little bit into the challenges we have in the space, and also like a little bit go into the tech and what technical capabilities we have. It's often a bit of a jungle when you work with tech, and but I hope to bring a little bit of a structure in it, and I try to stay not very technical, let's put it like that, but feel free to ask me questions if there's anything you'd like me to drill deeper at the end, and then some case studies. Yeah, hope you guys get inspired. Before I start, I'd like to thank all the organizations we worked with in the part and our collaborators. So they're really the core of the work I show today as well, and just like to acknowledge them briefly. Now, so when we look into intelligence and when we look into data, so often the question is a bit, what has actually changed, or what is different to what it was previously, and sort of also to address certain challenges we have in that space. So you can a little bit divide it up in 5 sectors, and I think just in general, the core driver why things are different, or the data we receive or process is different, is the internet, and it goes pretty much in almost every corner of our lives. And so we see it often then in our field as a progression from surveillance to intelligence, and eventually ideally to decision advantage. So when we look at the different areas, so I start on top with the volume, so unarguable. So the amount of data we have available increased dramatically. So previously it was megabyte, gigabyte. Now we are towards terabyte or petabyte. So there's the sheer amount of volume of data we need to deal with has increased. Then also the format of the data has changed over time. So when we go back, let's say 10 years, 20 years, most of the data we got was actually form of numbers, and maybe text was formatted in tables, maybe databases. And so that was the primary format, but now we also have to deal with different formats, and with a high variety of formats we got to deal with. So today we've got a lot of imagery. We can work with audio files, data on the web and also social data. So the variety definitely has changed, and we deal with other formats now. Also, the speed we get where we get access to data has changed. So back in the days, it was maybe okay to do a batch extract of data. Maybe there's a report that is produced on a quarterly basis or yearly basis. So that is still, maybe it's okay to manage that manually. However, so also the expectation of people to have the data available has changed. So it now goes more towards either near real-time data access or real-time data. So our audience often expects us to have data in a timely fashion available to make certain decisions. So that's the velocity aspects. Then there are also there's the value we provide out of the data. So there is also added complexity in that space. And so we bring in statistical process into the mix, which partly needs to automate it. There are certain events we got to react to, and maybe we got to pre-process or display correlations between data and access multiple data sets. Also, the veracity, I think, is a different aspect, and that's around the trustworthiness and authenticity of data. So often or sometimes it is not really clear where the data comes from or how complete the data is. And I think it's really important to expose methods and where the data comes from, and also make it really clear what data gaps are maybe available. So I go into that one a little bit later in one of the case studies. So I think a lot has changed, and we need to a certain extent deal with it. When we go into surveillance, intelligent decision advantage. So what is it? Maybe just a quick definition. So surveillance, CDC, it's ongoing systematic collection, analysis, and interpretation of health-related data, essential to planning, implementation, and evaluation of public health practice. Sort of intelligence, and then goes a step further. And that's about gathering information to actually make faster and clearer decision and eventual decision advantage, so that enables decision makers to better understand and address the issue. And it's a little bit bridging the gap between those two blocks, and how to actually go from surveillance to intelligence and to decision making. When we talk to people, so there are some perceptions out there, and we often get statements around that topic. And I just see a little bit of an opinionated and arbitrary collection of comments we regularly get for that space, and that reflects a little bit the challenges out there as well. Sort of one big question is, what are the best ways to provide insight into my data? So how often should it appear? Do I kind of push it out to people? Do I maybe provide a web interface where people can log in and access the data? So that's around how do I present it, and how do I structure the delivery method of my insights. And then the second one is what we hear a lot is our data is not in the right format right now to produce meaningful insights. I think that's a particular challenge in the health space, because often the data we deal with is incomplete. It can be messy, and I would almost argue it's never perfect. So we have to deal with a certain event with that data not being perfect, and also with things like partial data. So I show you some examples how you can deal with that. And then there's also, if I have something in mind, sort of that's the third comment. I'm not a data scientist or programmer. How easy is it to get started? What tools do I get? Sort of it's a bit of a jungle out there, lots of tools available. So where do I spend my time producing results or producing those insights? And then with the tool, it's also how long does it take to deliver something. When we go into the tooling space, sort of with visualization, dashboard tools, there are lots of sort of out-of-the-box tools available. They are relatively easy to access, so that's lots of you probably, or some of you guys might have already worked with it. So that's Tableau, Power BI, Click. So these are basically, you don't need any programming knowledge to access that. Totally viable solution if you look into more like the standardized outputs. So, and some organizations have that already readily available and you can use it. There always tends to be a little bit of a kind of a progression from that one, that you need outputs that are more customized. You need a better control of maybe how a dashboard or web interface is built up. And then it goes more towards a programming or scripted approach. And in particular in the health/research space, what are the probably most common languages out there is R and Python. So that's open source, but there are also sort of commercial products like SAS or SPSS available. Sometimes you start off with those ones, but then extend it with HTML, CSS, so with those common web technologies. There is a framework like JavaScript frameworks we can use, and we can extend that core sets. But an interesting one is basically to look into who is using those tools. So, and that provides a bit of guidance what's suitable and where to start with and maybe where to progress. So I've kind of just grouped people that might use it into 4 categories. And there's the business user. They don't want to get in touch with programming and they want easy access. Maybe it's like a bit like Excel, but maybe a better way to access data sources or a bit more flexibility. So these are those out-of-the-box tools, and they're totally fine to use it. And a lot of, let's say, business users or also analysts, sometimes data science, access those tools. However, when you progress a little bit into more custom solutions, sort of what is often the next progression is sort of going in that scripted area. So that's with R and Python. So now, and so the example I show you, so we've used R to produce them, and then R-Shiny, which is the web development framework that sits on top of R. So I'll show you some examples around that one. And in particular, R and Python have a bit of hybrid functions. So they are, so a lot of analysts, data scientists, researchers, it's really approachable to them. It's not sort of a proper programming language. It's like further down Java or ASP.NET, PHP, and so on, where you basically need a programming background to do that. But it is actually fairly approachable if you come out of the research space, let's say. And then, yeah, so also accessible for researchers. And when you look at programmers, so that goes more then towards those web technologies or common software technologies. The approach we take, so we like working with open source tooling and tools. And there are a couple of reasons for that one. And just like to highlight sort of four reasons why I think it's a good idea to invest time there, or maybe to take that as an approach. And the first one is reproducibility. And I think that's an important one when we look at that into that trustworthiness. And so ideally we have a validated solution. That means there is a sort of an easy way to give other people full access to it, so they can follow the script. They see exactly what methods you use, and then they can provide feedback and validate your solution. On the other end, if you work with a proprietary tool and maybe an out of the box tool, then often how you create charts or how you wrangle the data, that can be behind a black box and is less reproducible. So that's, I think, an important aspect to look at. Another reason why we like open source is resilience. So if you have work with a specific vendor, you are to a certain degree dependent. Vendors come and go to a certain extent, and with open source guarantees, because you've got the open source license attached to it, so it guarantees there's no specific vendor login. Even if a vendor supports open source technology, if the vendor goes, it can be forked, and the project lives on. So that happened, for instance, with MySQL back in the day. So Oracle bought it, tried to exploit it, and then it get forked, and it's now MariaDB, and it's still available. So it offers a certain resiliency. And another important one, I think, is participation. So with open source, you have the community approach, and you see that when you look, for example, into R packages. So I have got the chart to the right, and there's exponential growth because the community contributes to it. And that's also important because then really niche markets or niche areas with research, for example, or with health research get supported and made available to the community. And people can then look at the code, can use it and progress it from there. So it really helps the field to contribute and to share your finding. And the third one, so accessibility also comes in. So there's no license, a commercial license attached. You don't have to pay to access it, and it's free access for anybody. So that also goes back to university or schools. So students can be provided with access to it. So there's no complicated license, or so it's that idea of free access for anybody. So that's a little bit to look at with the tool set you're using. And so our preferred tool in that space is to use R. And there are different levels R actually addresses. So a typical scenario and aspect you have to address is ETL, so that's data extraction, transformation, and then loading. And so there are R packages. So R is really made for that one, and lots of possibilities to do that. Then you can use it for model creation, data analytics science, and R was already from the ground up when it was developed, I think 30 years ago or so. It had already the visualization aspect in mind. So in particular with libraries like ggplot or plotly. So you always have the base R, provides a solid foundation for statistics or the things above. But there's that wide variety of R packages. Then with R, you can produce certain outputs. Sort of just like to go a little bit into the most common ones. So there is Markdown and Quarto. So that is mainly for reports creation, and you can automate the process. Quarto is a little bit, so the Markdown won't be continued. So that was over the last years the go-to tool. So now, so that is parked there, that it's not actively developed anymore. So now it's moving to Quarto. So you can use most of Markdown for that. So those of you who already used it can progress using it. But Quarto is in particular handy when it comes to different formats. If you output to Microsoft Word and PDF, so with Markdown it was always a little bit more effort, but there's a more seamless export with it. Or then, so we work a lot with Shiny for dashboarding. So that's available, but there's also a lot of data connectors available where you can connect to databases, to your data warehouse, read in flat files, and so there's a range available. So it's also a specific format, so you can also bundle data objects into pins or use RDS, so that's a binary format our users, or also APIs are supported for that more real-time data extraction. When you look in the dashboarding end of my project related to intelligence, let's say, so the three kind of tiers you have mostly. So you have some sort of front end. So that's nowadays it's a web front end with browser access. So examples I'm going to show you are in the Shiny space. Then you've got a backend component where you do the data processing, where you've got maybe your model code in it, and where you also have the data connectors organized, and then you have the data backend, and it's often makes sense to split out those tiers. So that you have a certain independence. So for instance, you can also use the data for when you use off-the-shelf tools, let's say. So you can, it's not just locked into the specific scenario or maybe Shiny app you're building. So just like to give you some examples what you can do with our Shiny in that example, so with our Shiny dashboards. And so the screenshot you see there, that's of the aquatic invasive species explorer we developed in collaboration with the University of Minnesota. So that looks at infestation status of water bodies there. And so it provides sort of a risk framework and a risk prediction for water bodies to become infected. So with that one, so we already had, so are you guys actually seeing the?
No, I can't see that at the moment. No.
Just seeing the comment. Are you seeing my slide?
No.
No. Okay, I try again. Sorry about that. I share my screen, but let me try it again. What about now?
Now we can.
Okay. Okay, I had some nice graphics to show you, but Barry, I think we can probably share the presentation afterwards, so you can maybe flick through the slides, and I hope my explanation made sense, but maybe it makes even more sense when you see my slides. Cool. Awesome. So you can all see that now, is it? Yeah, so I hit my sharing button on, but not too sure why it didn't pop up. Cool. Now, all right. Now, so the screenshot you see there, that's of the aquatic invasive species explorer we developed with Minnesota. And so we had already model code available and built the dashboard interface around that one. So with our Shiny, it's really customizable what you show and what you can actually add to the dashboard. Then yeah, so that's the often when you launch into a project. So there might be a research project already in place where people worked with R for, let's say, a publication. So there's a relatively easy transition then to reuse the code for dashboard creation and then actually add those components, the filtering and visualizations, that you have an easier way to access results of your research. And it often also addresses that a timely access of results, because often when you do research or work with a paper or produce results for paper, so that it's a one-off effort, but it's often sort of an extra step to put that in production, and so it updates whenever the data is updated. Yeah, so Shine is really made for those dashboarding and often for the functionality we want to have available in the framework our Shine uses is reactive programming, so I can exactly control how filters are used, how the dashboard is updated. And for those of you who have already worked with it, so they might have already seen kind of that. So you build up those reactive chains, and it's a lot faster than programming it from scratch, maybe with those more common programming languages. What has been becoming a more and more increasingly popular feature in our dashboards is reports extraction. So you can interact with the dashboard, you can access results, and then we add a button there, and we use either Markdown, Quarter, or LaTeX to produce reports that are really specific to the filters users have chosen, and then you can extract a nicely formatted PDF report. So that's it's quite a nice feature, and sometimes call it freedom from reporting. So because you can actually extract those reports straight away, and it often saves you a lot of report writing because you can produce that on demand. And the report is then also more specific to what you want to see in it. I got back one more. So it's also increasingly becoming more important, so to have sort of that interface running on multi-devices. So with our Shiny, so we can also make it mobile responsive. So when we've got a smaller screen, it adapts to it, so it adjusts the interface accordingly. And so there's some inbuilt functionality there, but we can control that by building up the dashboard. So that's an example of the facial eczema dashboard. So that's for animals. So in that case, so the extent of facial eczema, so those buttons move then to the bottom, so I can use on the mobile my thumb to actually switch that. And so we really make that, particularly with that project, we program that on top. All right, I'd like to dive into a couple of examples, and I'd like to introduce you to one of the projects. So let me just bring that up in the back. So it's the double-check class. Yep, so just move that to the side for now. And then, yeah, just about the project. So it's a project we worked on with for the World Health Organization, and so it's around the GLASS report. So GLASS stands for Global Antimicrobial Resistance and Surveillance System, and we helped with the report creation, but we also produced a complementary dashboard. So the first part of the work was around the report, because it has a series of charts and tables and map visualizations in it. And it was, so the report comes out every year. And however, it was a really tedious project to produce those charts and maps. So we set up a series of R scripts which you can run through, and it produces the all the charts, maps, and tables in the report. So they still have a media company where they stitch it together then and provide all the contextual information to it. But there was a standardized way to create the charts, and so it saves them a lot of work. But the other aspect is with manual creation, it's error prone. So, and while having a script, so you can exactly follow the scripts, other people can check it, and you have a reproducible way to create the charts and tables. So, and then they also wanted to have a complementary dashboard to the report, and give you a little bit of a tour of it. So just switch that over. Can you guys see that one? Is it coming up? So it should say class dashboard. Or do you still see the slide?
Yep, we can see it.
So you can see the dashboard. Okay, that's good. So yeah, so the dashboard. So we just like to show you how we build it up. So you've got the link to the class report there, and then I've got 3 sections. So one is for global AMC data. So AMC is antimicrobial consumption. Then AMR for antimicrobial resistance, and then country, territory, or area profiles. So because that's the in detail country view into the MR and MC data. So when you launch into the dashboard, you get an overview which countries are enrolled into the program, and so we use a custom WHO R package for that one, because it's and it has the approved country boundaries in it, because some of the borders are actually in dispute. And so we wanted to support sort of the official web view of WHO in that. So we could integrate then the map visualizations they use in other areas as well. So that was quite handy. And so you can drill into the antimicrobial consumption. And so by default, so the last year available is 2020. So we're currently process to update it, and you can go into a region there. And then you get an overview of, it starts off with the antimicrobial classes. So maybe, so you get chart of hover. So we customize that one to exactly show what we wanted to see there. What we also did, we standardized the y-axis and so to which number we go there. So because the antibacterials for systemic use, so they had higher numbers there, but the other ones were relatively low numbers, but we still wanted to unify it. So you see that the first one goes to 60 and the other ones are unified to 20. So we programmed that, and so that you can more easily compare it if you would do nothing or use a standard tool. So it probably goes up to whatever the highest number is in the bar, in one of the bars. So we looked there pretty much at any aspect to make it as easy as possible for the users to get the insights and to get the results. What we also added sort of is for every chart we have in it, so you can download the image and you can then reuse it in a presentation, let's say, or you can send it to a colleague. And you can also download the underlying data. So that's in CSV format. So we also added a heading to that one, and when it was, I think, a date when it was downloaded. So some adds on we added to the dashboard. So and there are more detailed charts underneath. And I just quickly go into AMR. So that's we had those cyclic charts available, so which go into the implementation status, quality assurance, and so on. And you get an overview how the regions are enrolled into that one. So if they have a national surveillance plan or NCC set up. So it starts top level and then it drills more into detail. Because it's quite an extensive report, so we wanted to map it out on one page, because users are like Facebook or LinkedIn, so you scroll through and people are quite used to it. But we provide those quick links actually to the section of the report, so you can scroll down and then access the results. Yeah, there's also country and territory and area profiles, and that's so where you can access a specific country and get results. And one thing I wanted to show you there, so and that's how we dealt with data not being available. So when let me go to the UK. Here we go. So let's switch to AMR. And then, so we see in some section we have data available for some indicators, but in some aspects we don't have data available. So we still wanted to show that to also feedback some information. Okay, if you would provide the data, it would be available there, and just to show what the dashboard in the reporting would be capable of. So we still decided to show the section there, but have that message that this data is not yet available. If it becomes available, it would be shown here. So I think that's a quite nice way to deal with having incomplete data. All right, then cool. So that's like, so I think I've got another 5 minutes, so I've got time for another case study, and I've got two prepared. So either I can show you climate matching tool, or I can show you Epidemix, which is a sort of our so it's got a SAR model behind it, and so maybe I show the second one because that might be more topical for today. So you still get I have the link of the climate tool, so you can maybe also explore that after that on your own. So Epidemix is our disease modeling tool, so it's not there to predict the course of a disease. So it's a teaching tool, and it should help people to understand disease dynamics. So we've worked with Professor Dirk Pfeiffer, so he's now at City University of Hong Kong, and Guillaume Fournier, so from Royal Veterinary College in the UK. I think he moved on now, but most recently. And so it's one of, I think, the most longest running dashboards. We've worked on it over the last 5 or 6 years, and over the years we added more and more features to it. So let me quickly bring it up, and I can show you a little bit around. So it is freely available and openly available under epidemix.app. And sort of when you look at it, so we have different disease models in it. So I think it's a total of 8 or 9 different models, and we also have some disease-specific models. So currently it's COVID, AS, and avian influenza model in it. And yeah, so just wanted to highlight a couple of features we recently added, or that we added over time. So you can, there's a whole series of parameters. So we have a default selection, but then there's also an edit button where I can change that. And sort of for the outputs, I can download the parameters and re-upload it, or I can also share it with others. So it's sometimes gets used in seminars, and then the teachers can then share the parameters they use and explain sort of different disease scenarios about one. So that's quite a nice feature. Another one, what you can do, and we recently added, is a parameter compare function. So let me quickly show you that one. So that's so I got to choose control strategy, vaccination. So that's for animals, but that's why you see the culling. And with parameter compare, so it when I select, want to compare different control strategies, and yeah, it's the proportion of vaccinated units. So it pulls in my preset here of so 0.5 or 50% of the population are vaccinated, and then I can compare it, let's say, to a lower number and to a really high vaccination number, and I can see how what the difference is. So, and can hover over how particular there's susceptible, particular infectious symptomatic, how it basically flattens the curve. So that's probably what you would expect. So lots of parameters you can set and play with, and so feel free to go there and explore it. I'm not too sure if you have already previously seen it. So we also the network model is quite a good one to show, because you see how the disease spreads through a network, and we have some visualizations around that one available. Cool. So it was a really quick tour for Epidemix. So we have tutorials on the Epidemix. So website is epidemix.app. There are quite a lot of case studies and tutorials on there. So if you're interested in, yeah, so have a look there or reach out to us. Yeah. Cool. So just looking at the time, almost there, and so just wrap up a bit here. So and wanted to forward a couple of resources we have available. So we try to sort of, as we work with open source, we also like to give back. So we regularly publish sort of some functionality we produce, and we think it might be also useful to others. So we have our Epi-interactive GitHub page where you can look up, download the code. We also have a bit of a write-up. So for instance, how we program that PDF generator. So you can, so feel free to go there. It's freely available. Then yeah, another one. So we've got some of you guys might already seen it or might join. So we've got our exchange event next Friday. And so if you can make it, so it's in Wellington in the National Library. So it would be great to see you guys there. And for example, the climate matching tool will be, so Ursula Terrace from Minister of Primary Industry will be the end present the climate tool if you want to have more details around that one. Then yeah, so I just wanted to transition over to any questions, and yeah, so Thanks for listening. Sorry about the glitch at the start with the slides, but hopefully you just could lie back a little bit and or lie in the sun and then listen to my voice. Yeah. So yeah, thanks a lot for joining, and yeah, open for any questions or discussions.
Thanks, Yuli. Excellent. I have a question, but somebody in the chat has got a question. I don't know if you can see that. How do we make advantages of open source technologies allowed for use by health data analysts? As employees of the MIH, we have basic Microsoft 365 license, no access to the advantages of 365 Azure platform and allowed. Me personally struggling trying to get it for 2 years, at least from our health provider Health Alliance. Don't know whether you've got any advice, solutions to that particular person.
So that's that would be around access to open source tools in a restricted environment, is it?
I think so, yes.
Yes. There is, so a little bit with also we see a lot of organizations start with, or at least have some sort of support, is with Osto Desktop. So that's software you can install on the laptop, and so I know sort of in New Zealand, in some government organization, it is already sort of approved software. You might still need to go through a little bit of a process to get it. There are also professional products available from Osto/POSIT, so POSIT is the new name they have. And so they offer also commercial products. So we worked with several New Zealand government organizations to get that in place, and that's a browser-based environment where you can then program R and Python. And but that might be, so some, like I know Ministry of Health, they've got it set up, Department of Corrections, and so some organizations I know they already have it in place. So it might be a matter of maybe reaching out and see if that's already there. You can use. Otherwise, yeah, if it comes up, we will be happy to help, I guess. Yeah. Hope that answers your question.
One other question from Mike Keenan says, have you been tempted to use Julia?
We haven't. So I think Julia is that Python environment, or so I heard about it, but we haven't used it. Yeah. So I think from Mike, maybe you can expand the if you used it yourself, or what your experience is with it.
Yeah, Mike.
Hello, can you hear me?
Hello.
Yes.
Yeah, so I used Julia prior to working in the health sector, and we really struggled to even support R or Python. So if you're interested in doing exciting things, I've found it a pretty tough environment to sort of let rip in. Yeah. But yeah, Julia's programming language, it's got a lot of probably 10 years of extra research after Python was designed and implemented to make it higher performance and just generally easier to work with.
Yeah, there might be another one for as a tool set. So we haven't worked with it, so I can't really comment too much on it, but I'm sure it's a yeah, good tool to use, or to use it for your purpose. Yeah. No, thanks.
Thank you.
Really, with the current push towards AI, how do these tools work with AI, or do we need all these tools with AI around?
That's a very good question. So, and we have, in fact, sort of some interest in that space, and I think it can come in is when we look into, so one use scenario is, and there are already sort of a ChatGPT, so there are already some specific implementations out there to produce visualizations. And so we had already a bit of a play with it, and it I think there's also integrate, or R is supported as the language there. So what you can do is actually formulate a question or an output you want to see and let ChatGPT create it. And there are sort of APIs available where you can do that. So I think there are opportunities to speed up the process to create outputs. Sort of we already had a bit of a look at the visualization end, but there's probably also opportunities from the analytics or maybe accessing data to kind of fast track that one. We are a little bit skeptical is validation, and so that you produce or you have that reproducibility in place, and have sort of can really track it down where it comes from, what exactly is happening, so that you don't have a black box approach where you get an output and then think, yeah, looks maybe right, but I'm not too sure actually about it. So that trust and validation aspect, I think, will be a really good one, but I think there will be lots to come. I mean, with the whole AI, it has been lots of talk, even going back when I went to uni 30 years back or whatever. So it was already on the table, but it seems like it is a bit of a breakthrough now, and I think we will see quite some applications also in our field, I guess. Yeah, but yeah, a little bit hard to predict. So how far it will go. Yeah.
One of the things that you're mentioning right at the start, which I think is absolutely critical with the amount of tools that are around, is the interpretation of what those tools are actually producing. And I think that is where there's a current deficiency in that one area. And I think that, I mean, what's your view of that? I mean, the question is the so what? What does this all mean? And we know that people are getting information from all over the place, Paul. I mean, I think ChatGPT is an example of this. The question is, so what does it mean, the interpretation? But how, I mean, when you're designing your wonderful tools, how do people respond to that?
So how we come, or so the scenario we work in is often, so we work with research institutes or researchers or analysts who really have a in-depth subject matter expertise in a specific area. So I think nothing's going to be replaced that one, because you need to be familiar with the topic and the environment. You need to have ideally a network of people you can connect with. I think so. Sort of there, I think that research component is important, so that you use a method that is sound and it's also validated. It is ideally peer reviewed from others, and then it's a matter of translating that into tool set. And what we often do is when a model is created, let's say, so that we have that as an R function available. It was already used as part of a publication, and it was validated. And we also make that accessible in a let's say dashboard, that people can read it up, can read the publication. So for instance, with Epidemix, so there are publications around the models we use. So I think it's important to provide that information, what methods are being used, so that it's not a black box. Yeah, I think it's just, so sometimes when you look at dashboards, you simply don't know where the data comes from, or what data is used, or what gaps there are, or what methods. So I just want to be very conscious of that should be really exposed, and I think a good dashboard should have that that information available, at least link to it, and provide that kind of that level of validation.
Yep, I agree. So there's there's always going to be a need for people with expertise in the areas.
I think so. And my personal opinion, it's that will be hard to replace. So even AI tools or so, it's having that level of understanding. It's either we are still some years away, or I'm doubtful. Kind of, and when we look at that decision advantage or health intelligence, even so, how they can be kind of replaced. So, but who knows?
Is there anyone got any further questions for Yuli? Doesn't seem to be. Yuli, on behalf of the PHONZ and the people who have been here today, thank you for a wonderful talk and demonstration of what you and your group have done. Wonderful tools that you've generated. So very much thank you for that.
Yeah, cool. And I believe we, so I'm happy to share the slides, and so also have a look on our, so all 3 examples I mentioned, so they're all available on our website. So go to epi-interactive.com. So, and they are freely available. So we've got the links added there. So if you want to explore them, and there's also a bit of a write-up there, what it is about. So feel free to dive there and explore more. Thanks a lot for joining, and also to Barry and Patrick for organizing it.
So if you send us the slides, we can put them on the website as well.
Yes, yeah, so I'll do that. Cool.
I'd just like to remind everybody that's still here that the second PHONZ virtual conference is on the 19th, 2021, and the themes this year are public health ethics, implementation, and communication. So registrations for that are open on the PHONZ website. We've got a list of illustrious speakers this year, focusing on public health ethics, implementation, and communication. So I encourage you all, you and your colleagues, to register for the conference, and that happens on the 19th, 2021 July, from 9 to about 1 o'clock. So thank you, everyone. That concludes the webinar. Once again, thank you, Yuli, for a wonderful presentation. Thank you.
Thank you. Thanks, guys.